Again, welcome back to my YT channel. This is again, I am a senior channel voice, your YouTube content creator, small YouTuber, and your social media influencer. I am Engineer Sotero Nepomuceno Jr., a Bachelor of Science in Chemical Engineering graduate of Cebu Institute of Technology University. And now I am shifted to occupational safety and health career path. And here I am now, I'm also vlogging daily a la tool with regards to pure science and a little bit lecture of math. And it's gonna be a very enjoyable moment at also disappointing time. Okay, going back to the topic. Nasapit na po akong tila mga palangga because I am a pure Cebuano. Okay, going back to the topic for this moment. It's gonna be chemical equilibrium problem, and I want to give another example, a reversible chemical reaction. Okay? Because most of the times I give you an example, irreversible. Now, it's gonna be reversible reaction. Okay? For example, for this is just like the nature of hydrochloric acid, hydrofluoric acid, what else? In the 7A family, hydrobromic acid, okay, and hydroiodic acid. I'm gonna choose hydroiodic acid. Okay, yes, HI. Di ba mga balangga, HI? Yes. Okay, ganon. Okay, HI. Okay, chemical equilibrium, ganon. Okay, chemical equilibrium. When you talk about chemical equilibrium, it needs to link to the principle of Le Chatelier's principle. You know that one? That is a theory that states that whenever a stress is applied to a system of equilibrium, the equilibrium will shift to the direction so as to reduce the stress. Something like that. Okay, I memorized this when I was in high school. Okay, this principle. Okay, I can still remember very exactly the definition of Le Chatelier's principle. It's gonna be the stresses, what they mean there are temperature, pressure, concentration, the exothermic and endothermic reaction, and then the energy. What will happen? It will shift to the right, shift to the left. If you add the concentration in the right, what will happen to the reaction? It will shift to the left or not, like that. So it should be in a state of equilibrium. To compensate that, moles, okay, the exothermic and the endothermic reaction or internal energy or whatever, okay? So it's gonna be like that. But we don't touch that. I'm just saying it's being connected to this topic, chemical equilibrium, right? Get the point. Now I give you an example. I will fabricate a question. Something different. Okay, say for example, four ba? Sige. 20 moles of hydroiodic acid, okay, in a 4-liter flask. Okay, say for example, in a 4-liter flask, something like that, okay, decomposes into, okay, hydrogen gas and iodine gas, okay, like that, decomposes into hydrogen gas, H2 and iodine gas. Okay, the equilibrium, okay, number of moles, let's say I will reverse this one. The hydrogen gas, okay, has 8 moles, okay, in an equilibrium. The hydrogen gas has 8 mole in an equilibrium. Okay, like this. Okay, or at equilibrium. Okay. Calculate the concentration of H2, I2, and hydrogen, hydroiodic. Okay, hydroiodic gas. Something like that. Okay? So guys, this is technique. In chemical equilibrium, guys, we don't include the solid and liquid. We always base the aqueous and the gas phase or the vapor phase. Okay, that's very clear. We don't include that in our equilibrium concentration expression constant, something like that, or the what we call as KC. Okay, something like that. So I have HI decomposes into reversible reactions, so two arrows, right? Like that. H2 plus I2. Okay. Actually, there's an example like this also, but I only modified because the example is a little bit easy and I want to modify something for further understanding, something like that. Okay. So H2 plus I2, like that. And then balance the chemical reaction to most of the balance. 2 hydrogen, iodine, 2. Oh, balance the shot. So this is all gases. Gas, gas, gas. Okay, so there's no solid and liquid, huh? Okay. Now, the equilibrium Kz is equals to the concentration of H2 raised to the power 1. Okay. Then I2 raised to the power 1 also. Okay, and hydroiodic raised to the power 2. The number of coefficient will be the exponent in the chemical equilibrium. But in chemical kinetics rate law, it is not. It is not the coefficient, right? Later we will be touching a little bit with chemical kinetics basic. Okay, not the chuba chucho. Okay, like that. You get the point. Now in this manner, guys, we need to have the initial changes and equilibrium. Ganon. So the ICE technique. ICE. And then we have like this. Okay. HI. Tabulate this. Okay. In chemical kinetics, this is called initial rate method. Okay. Like that. But in here, simply putting in a table for the purpose of easy understanding of how to solve the equilibrium constant of the concentration. Ganon. So HI, okay. Makita mga palangga? Wow, makita. In fairness. I2 and H2. O diba? Okay. Tabulate. Ganon. Okay. Now, initial concentration of HI is 20 moles divided by 4 because concentration is always molarity. Okay. But I found in every example always given the molarity. So I want to be, not all the time like that. So that's why I specified 20 moles later like that because it will be modified also somewhere along the way in the future examination. 20 moles divided by 4 liters. It's gonna be 5 moles per liter, then it will become 5 capital M or 5 molarity. Oh, ganon. So the unit of your HI all here in capital M, capital M, capital M, or moles per liter. Okay, ganon. HI is 5. Oh, ganon. Initial, we don't have initial for H2 and I2 because H2 and I2 are not in the reactant. Of course, it's 0. 0, 0. For the changes, mga palangga, for the changes, we let X as the concentration of hydroiodic gas, okay, to appear in the chemical reactions. Gonna be, ganon siya. So, 5 times X. Again, this is the chemical reaction. Go to the stoichiometric relationship. So, it's gonna be X times 2. 2X. In the changes, this is a technique also, guys, because there's a technique how to solve. The changes will be referring to the stoichiometric number of moles in the coffee, the balance chemical reaction. The same as in the dimensional analysis of solving the problems, the step 2 will be basing on the stoichiometric relationship of the balanced chemical equation. Then you can solve whatever chupa-chucho. It's also like this, the balanced chemical equation will be considered. So let X is the concentration of HI change. Okay, like that says negative 2x, because by the theory states that the rate of the forward reaction is equals to the equilibrium constant concentration of HI raised to the power 2. Ganon. Okay? Now, the concentration of HI will be reduced. Okay? The rate of the HI will be reduced. Or the concentration itself, because rate of reaction and the concentration are directly proportional with each other. So it's become negative. It will be given to H2 and I2 in a chemical reaction. So H2 and I2 will be positive. They will receive more the concentrations coming from the HI. So it's gonna be negative 2x and then x and change because unknown, right? We don't know really the x of this H2 and I2, the concentration that change. Okay, for the initial. Now, equilibrium, we have to add the initial and the change. Okay, we add that because we need to equal that. And then if you add that one, it will equal to 0. Then 5 minus 2x. It's just like 5 plus minus 2x, like that. It's equal to 0. So that's 5 minus 2x, diba? 5 minus 2x. And then 0 plus x and 0 plus x. Because there's no number of moles of H2 and I2. That's why 0. If have, you can simply say 2 plus x. Okay, you get the point. Okay, and then 3 plus x, but there's nothing there. That's why. You get the point. Okay. Ganon. So, how can we solve this one? So, the other condition states that mga palangga, the hydrogen gas 8 moles at equilibrium. 8 moles. So, we have hydrogen gas is equals to 8 moles. And since we know the flask is 4 liters, then we have to divide that also by 4. So, 8 divided by 4 is equals to 2. And this is in equilibrium. So if this is an equilibrium, I will say 0 plus x is equals to 2 because there's concentration given in the equilibrium. 0 plus x is equals to 2 or x is equal to 2. Like that. You get the point? Ganon. So x is equals to 2. Therefore, x is equals to 2, and then 5 minus 2 times 2, then 1. So, very easy, right? Nakakaloka. Okay? It's gonna be solved immediately. 1 mole per liter, or 1 molar of HI at equilibrium, 2 moles of I2 at equilibrium, 2 moles per liter at equilibrium, and H2 2 moles of letter of equilibrium. Why equal ang concentrations sa I2 and H2? Because both of them have the same number of moles or coefficient in the final balance chemical reaction. Now, we have 1 in the equilibrium. The 5 will be reduced. Okay? From 5, initially, it will now become 1. Okay? You get the point? So this is gonna be like that. Now, if you give them the equilibrium, if you compute the equilibrium constant, then you can compute that one also. So, equilibrium constant is equals to, but in here, the equilibrium constant is not asked. It is only the concentration of H2, I2, and HI. But if the problem will say, guys, calculate the concentration, that's understood to be at equilibrium, Remember, it doesn't have to say, again, calculate the concentration at equilibrium, H2I2. No need to put equilibrium. That's understood already. You get the point? Okay, most of the problems, we never mention equilibrium in the what is being asked. You get the point? this understood that what is being asked usually at equilibrium. Okay, because usually the initial will be the given, something like that. Okay, with the point. And you solve the equilibrium constant of this situation, we can say, okay, ganon, substitute. Kc is equals to, okay, 2, because raised to the power 1 is simply 2, right? And then hi is 1. 1 raised to the power 2 is simply 1. So Kc is equals to 4. Kc is equals to 4, meaning there's no unit, mga palangga. So the equilibrium constant of expression of the concentration of this hydroiodic gas converted to hydrogen gas and iodine gas will be equal to 4. Oh, ganon. You get the point. Now I have to introduce to you some theories and principles regarding this one. Okay, like that. Okay, this is not emphasized very well in college, but I research. Okay, okay, so that's it. Okay, so if your Kz is greater than 1, you will produce more of the concentration of the products, or your concentration of the products will increase. Okay, or your numerator, okay, or your numerator of your equilibrium constant expression, if you try to multiply that all, is bigger than the denominator. So that is your identification. Okay, and then if your Kc is less than 1, meaning to say the chemical reaction, rate of reaction will favor to the reactant. Meaning to say there will be more concentration of the reactants. Okay, something like that. You get the point? Meaning to say the denominator is higher on your numerator if you try to multiply that. Okay, you get the point? So meaning to say if you solve Kc, I have 4 here. Right? So Kc is greater than 4, right? Greater than 1. So 4 greater than 1. So my reaction, chemical reaction rate will favor to the product here. Okay, favor to the product here. So meaning to say these products have more concentrations compared to hydroiodic gas. Okay, you get the point. And then if I will substitute that values individually, okay, it is greater. You get the point? Because 2 times 2 is 4, and that is the product in the numerator, and then 1 only in the denominator. So greater ang product. Inuunan ko na favored to the product and more concentration of the products, or will shift to the product. Something like that. You get the point? Shift or favored, maura yun na siya guys ha? Shift the reaction to the product or to the right side, or increases more of the concentrations of the product, something like that, okay? Or will favor to the product side, ganon. Okay, because Kc is directly proportional to the chemical reaction rate R. Really, Sir Sotero, how can you prove that? Okay, like this, okay? Reaction rate forward, okay, is equal to K, the concentration of the product. Then solve for the K. So K is equal to R of the product. Therefore, equilibrium constant of the concentration is directly proportional to the rate of the forward reaction. Ganon. So we can say directly proportionally siya ang hidayunan. Or we can say also that P, concentration of the product, is equals to ganon, equilibrium constant and rate of the reaction, or rate of the forward reaction. So rate of the forward reaction is directly proportional to the concentration of the product, or simply say rate of the reaction is directly proportional to the concentration. Okay? You got the point. Ganon na siya. Okay, now if you talk about reaction quotient, ito ko sabot ng reaction quotient when I was in first year college, guys. Natuog siguro ko. I was sleeping when my instructors discussing this. Sure. Okay? Okay? Or maybe that was very long time. I could not remember. Okay? Reaction quotient for this, guys, is gano'n lang siya represented as capital Q. Okay? Reaction quotient is equals to H2. Okay? Gano'n-gano'n, 2 ba? 2, I2, and the same thing, the coefficient of each will be raised to the exponent over hi raised to the power 2. Ganon. And then we have also the relation of reaction quotient and the Kc. O ganon. So, what is siyang inversely? Ang Kc ang reaction quotient. You get the point? Okay, if the Kc is greater than Q, then siya, chuba-chuchu, and then your reaction will shift to the reactant, or favor to the reactant, or more concentrations of the reactant. And then if your Kz is less than the Q, then therefore we conclude your chemical reaction will shift to the product, and more of the concentrations of the product will be produced. So relationship siya. Okay, ganon. You get the point? Oh, ganon. So this is only to prove if your answer is correct or not. Okay? You get the point? For this reaction quotient, equilibrium constant, chuva, chuchu, ganon. Okay? Any questions so far for this? Okay? This is reversible reaction, ha? If you add H2I2 will go back to hydroiodic gas, even if without adding energy or without any chemical energy involved or any external energy being added or any process involved. Natural lang yun na siya, guys. Bubalik rin sa iyang reactant. Okay, you get the point. So, a reversible reaction. Reversible reaction or non-spontaneous. Negative delta G. Ito ba? Positive delta G, sorry. Spontaneous is negative delta G, right? Okay, get the point? Gives free energy. Okay, so chemical equilibrium ganon. So any questions so far for this? Nothing? Okay. If you like, comment, and share, then you can do it. You can subscribe to my channel, and then you can click the notification bell for some newest updates of I Am a Singer, Eternal Voice. Bye-bye, everybody. See you later. Ganon. Diba?